So we've already dealt with exponents. Now we're going to talk more about radicals. So radicals are another name for roots, and we're going to talk about some of their properties to start with. Now I'm splitting this section 7.4 up into two different pieces. I feel like it's got a lot of stuff, so I chose to do two separate sets of notes for it. So first, the product property of square roots. So if you have the square root of two things multiplied together, you could split it up by separating it into the square root of the first times the square root of the second. In other words, if I had the square root of 2x, that's the same thing as saying the square root of 2 times the square root of x. And the same thing is true here, the quotient property of square roots. So one way this can be helpful is, let's say I had the square root of 9 over 5. Thinking, oh, well, I can't take the square root of 9/5, at least not without a calculator. But if you split this up into square root of 9 over square root of 5, square root of 9 is 3, and this one we just leave it as it is. So the point is that if you're multiplying or dividing inside of a square root, you can split it up into two different square roots. And you can also go this direction too. If you've got two square roots, you can combine them into one by multiplying or dividing. So we do often estimate or round off the answer to roots that don't come out even, like when we plug in the calculator. But the reason we actually are going to do this is we can keep the answer more exact by simplifying it and leaving it in radical form. In other words, writing the square root of 2 is actually more accurate than saying like 1.41. Now 1.41, if I'm remembering right, is a good estimate and a good rounding off of it, but square root of 2, written as square root of 2, is more precise. So to simplify a radical, you need to first consider the factors of a number. In other words, what numbers can be multiplied that would equal this number. And you want to find the ones that are perfect squares. Because if you think like up here, the 5, we separated it, but we couldn't do anything more with the 5 here or here because we don't know the square root of 5. It's not a whole number. But the 9 is a perfect square because we can take the square root of it and get a whole number. So once you consider the factors of the number and find which ones are perfect squares, you rewrite the number as its factors being multiplied. So let me try to talk through this with the example right here so you don't just think it's all abstract. Let's say we were told to simplify the square root of 50. So you might go through and think, okay, you don't have to write this unless you want to. I'm just trying to write what you might think. Let's see, 50 is 2 times 25. 50 is also 5 times 10. I think that's the only factors we could use. 1 times 50, but doing 1 never really helps anything when you're doing this. So then we look and say, okay, 5 is not a perfect square, 10 is not a perfect square, 2 is not a perfect square. Oh, but 25 is. I know the square root of 25, or at least you should. So we use this pair, and we rewrite the square root of 50 as the square root of 25 times 2. So this is where we apply the property we learned up here. If two things are being multiplied inside of a square root, I can split them up. So then we do step 3. We take the square root of the perfect square, which is the 25, and we write that answer on the outside of the radical. So you see how I took the square root of 25 is 5, and I wrote that outside the square root of 2. And we'll leave the non-perfect squares, the 2, inside the radical. So the things you can take a square root of go outside the radical. The things you cannot take a square root of go on the inside of the radical. Okay, so number 1, we have 28. So 2 times 14, that is 90 perfect squares. 4 times 7, we do have a perfect square there. So because square root of 4, I know that. So square root of 4 times 7. So it's the same as square root of 4 times the square root of 7. And we can take the square root of 4, so we write it 2. We can't take the square root of 7, or it's not a whole number, is what I'm saying when I say we can't. So we leave it inside. So the perfect square, we take the square root and put it outside the radical. The thing that's not a perfect square, we keep it as it is and leave it inside the radical. So the square root of 28 is the same as 2 times the square root of 7. Okay, number 2, 68. Okay, 68. That's divisible by 2, so let's see, 2 and 34. Neither of those are perfect squares. Okay, 34 is also divisible by 2, so that must mean we can put 4 in here. So 4 would go into 68 17 times. And you can guess and check these in your calculator. If you can, off the top of your head, think of ones for things like 68. I mean, I know 28 is small enough. You can figure that out pretty quickly. But with bigger numbers, it's okay to use your calculator to guess and check and see what works. So here we do have a perfect square. So I'll say the square root of 68 is the same as the square root of 4 times 17. And I'm allowed to split this up to be the square root of 4 times the square root of 17. The square root of 4 is 2, so I put it outside the radical. The square root of 17, we can't take the square root of, it's not a perfect square, so we leave it inside the radical. Okay, number 3, we're going to first, in this one, these weren't already multiplication or division. This one is. So I'm going to first split this up into the two different radicals, because we're going to need to simplify the top and the bottom separately. So first I'll think about 27. 27 is 3 times 9. Hey, and 9 is a perfect square, so we'll use that. 48, let's see, we have 2 and 24, no perfect square there. 4 and 12. But you shouldn't stop once you find one. I didn't say this earlier and I should have. You should list all of the factors, because sometimes, like in this one, we have 6 times 8 is 48. We also have 3 times 16. So notice we have two pair that both have a perfect square. We have a perfect square of 4 and a perfect square of 16. So when you have two perfect squares, you should always choose the one that's bigger. And that's because if I simplify with this one, I'd actually be able to simplify it even further by trying to simplify the 12 part. And that's still possible to get it correct, but it's just more work than you probably want to do. So the top one, I'll write the square root of 9 times the square root of 3. The bottom, I'll write the square root of 16 times the square root of 3. Okay, the square root of 9 is 3. The square root of 16 is 4. And this won't happen every time, but notice we have square root of 3 over square root of 3. Well, any number, even if it's a weird radical, divided by itself is equal to 1. So those cancel out because they are equal to 1. So our final answer is 3/4. Okay, number 4. This adds in exponents with, variables is what I wanted. This adds in variables. So let's look down here. To deal with exponents, and that's usually going to be with variables, pull outside of the radical the number of times 2 goes in the exponent. So right here, 2 goes into 5. Let me go a little closer. Two goes into 5 2 times. So I know a y squared can come outside. Because since 2 goes into 5 2 times, 2 y's, y squared can come outside. But that leaves a remainder of 1, and you leave the remainder inside the radical. So y to the first is left on the inside. Now, you don't have to write the to the first power, but you can if you want to. Okay, but I did get a little ahead of myself. So I just want to make sure I explained how the y part will work. So let's look at the numbers now. 18 is 9 times 2. So I can write this as the square root of 9 times the square root of 2 times the square root of y to the 5th. And the square root of 9 is already a perfect square, so I can just say 3 for that. So I split 18 up into 9 and 2. I just rewrote the y to the 5th. The square root of 9 is 3. That's already a perfect square. Okay? Now, square root of 9 is 3. And here's where we do the trick down here. We say, all right, how many times will 2 go into 5? 2 will go into 5 2 times. However, 1 will be left over. So we have the 2 still inside and 1y left inside. That's all divided by the 3 on the bottom. So I did the square root of 9 is 3. Square root of 2 has to stay inside the radical. I say, how many times can 2 go into 5? That's 2 times, with a remainder of 1. So the remainder, that many stay inside. Then we notice there's a 3 on top and a 3 on the bottom. So this can be simplified into y squared square root of 2y. Okay, here we should do what I talked about back up here, the fact that we can go either direction with these properties. Because square root of 3 we can't do anything about, square root of 3 we can't do anything about. However, if we combine these, we say, well, the 5 is a coefficient, we just need to leave it out front. It's already outside. Those on the outside don't mess with people on the inside, and vice versa. 3 times 3 is 9. X squared times x squared is x to the 4th. So this is the benefit of combining them. 3 times 3 is 9, and that is a perfect square. So I have 5 times the square root of 9 times the square root of x to the 4th. The square root of 9 is 3. 3 times 5 is 15. 2 goes into 4 2 times, and there's none left over, no remainder, so we don't need a radical anymore, because 2 goes into 4 4 times. So we end up with 15x squared. Last one, square root of 150 times a squared, b to the 4th, c to the 1st. Okay, so let's think about the 150 first. I could do 2 and 75, no perfect square there. I could do 3 and 50, no perfect square there. I could do 5 and 30, no perfect square there. We could do 6 and 25. There we go, 6 and 25. Because the only other combo, I think, is 10 and 15. So the only perfect square we see is the 25. So I'm going to split up the number, be the square root of 25 times the square root of 6, and then we'll deal with all these, 2, 4, 1. We'll deal with all the variables after we deal with the numbers. So the square root of 25 is 5. Square root of 6 is not a perfect square, so it gets left on the inside. I just left extra room here because of the variables, because I want to make sure I have room to write them in. So I say, all right, how many times does 2 go into 2? Well, it goes in 1 time, so that's a to the 1st. It comes outside. And there is no remainder for the a, so it just stays, or it's only on the outside. 2 goes into 4 2 times, so we can bring out b squared. And there's no remainder, so there's no b left inside. But we can't put 2 into 1, so that means no c's come out. So there's a remainder of 1, and it stays inside.